Hi, this is Daryl Lewis-Sandy from Mana. Welcome to the 5th video in our training series about the Physical Quantity Service. The Physical Quantity Service is a GraphQL-based microservice that provides the capability to parse and extract physical quantity mentions from strings, to perform unit of measure conversions, and to perform arithmetic with physical quantities in a way that respects their physical dimensions. This video series uses a workspace service template that contains the exercises for all the lessons that we'll be working through. If you've been following along with us on our previous videos, you already have a copy of this workspace and should open it now. If you've just joined us, you should take a moment to clone a copy of the Physical Quantity Tutorials workspace. Go ahead and pause the video here. I'll wait until you're ready to proceed. Today we're going to be working through Lesson 4, Extracting Text. So go ahead and open that knowledge graph. We'll be creating a function called Extract Physical Quantities from File. And as with our previous lessons, this knowledge graph comes pre-populated with the kinds and functions that we're likely to encounter during the course of this exercise. We can see that we're likely going to need the extract text function and the add text input kind from the Mana Loader service, and the extract function and entity mention kind from the Mana Physical Quantity service. If you're familiar with the ManaQ platform, you've probably already encountered the Mana Loader service and maybe even used the extract text function. The purpose of this function is that given a file locator in the form of an add file input instance, it will retrieve the full text of that document. For example, if I give it the URL for the full text of Alice in Wonderland from Project Gutenberg and run it, after a moment, you can see that it returns the full text of that document. We've already used the text processing functions from the Physical Quantity service many times, and we understand how the parse function works. If we give it a surface form for a physical quantity, in possibly weird units, and possibly surrounded by white spaces, it will parse a physical quantity, returning to us the physical quantity structure in normal form. However, the parse function is designed to take a single physical quantity, and if it's surrounded by anything other than white spaces, it will fail. The extract function, on the other hand, is designed to take a text document and find all the physical quantity entities that are mentioned in it. In addition to returning us the physical quantities that are found, it also returns to us the location of the start and end of the physical quantity in the document. Since physical quantities are such distinctive entities, knowing where they are inside a document may be very useful when you're trying to locate and extract additional facts from the document. So let's try this function out. I'm going to paste in part of a scientific protocol that I copied from online. After a moment, we can see that it's found 9 entity mentions, including temperatures, times, volumes, and masses. And for each of them, it's returned to us not only the physical quantity in the value field, but the start and end location in the document, which includes the offset in characters and the line number that it occurred on. You should now have all the tools you need to solve today's exercise. Why don't you pause the video here and see if you can come up with a solution. Welcome back. Now that you've had a chance to come up with your own solution, let's walk through mine together. Now I know that I'm going to be creating an implementation for the extract physical quantities from file function, so I'm going to start by opening up that function graph. I also know that I'll need the extract text and extract functions that were on the canvas, so I'm going to bring those in here. All right, so let's take a look at this. We're given an add file input, which specifies the location of the file that we want to extract the text from. We want to extract that text, And then we want to get the physical quantity entity mentions from the string that is returned. This gives us a list of entity mentions, which we can return as our output. That was pretty easy. Let's see if it works. So I'm going to select the Run dialog here, and I need to give it a location of a file. I'm going to give it the URL here of Lewis Carroll's Alice in Wonderland from Project Gutenberg. I'm going to paste that in there and press Run. And after a moment, we can see that it's extracted 45 physical quantity entity mentions from that document. And if we look at them, you can see that we had a mention of 60 days at offset 151,872 in the document. We had a mention of 30 days nearby, about 1,000 characters away. At offset 152,663, there's a mention of 1 farad. It's unlikely that a book that was published in 1865 had units in the metric system in it. So let's see if we can modify this function slightly so that we can choose what system of units we're using for the extraction. Now if we look, we could see that the extract function has the same optional arguments that the parse did. It's got a system of units and it's got a physical dimension name. So let's go ahead and modify the input to this function so it takes a system of units, IDs, and this is a list of IDs. We'll save that. We'll pipe that through. So now when we run this, we could tell it we only want it to parse units of measure that are from the imperial system. And run this again, and we should have fewer false positives. And after a moment, we can see that we found 31 entities instead of the 45 that we found before, and that that mention of 1 farad, if we look here, there's 90 days, that makes sense. And you can see the 30 and 60 days, but the 1 farad mention is gone. So we can use the optional arguments to extract to fine-tune the results that we're getting back from our extraction. If we're working with a document that's from a technical domain, we might want to use a domain-specific system of units to ensure that we get the correct extraction results. That just about wraps up today's lesson. I hope that you had fun learning about the extraction features from the physical quantity service. Next time, we'll be learning about persistence of physical quantity structures. I hope that you'll join me then. If you enjoyed this video and want to learn more about the physical quantity service, don't forget to subscribe to the Mana Inc. YouTube channel